an advantage here, but guys, you've just got to learn this story. Anyway, hello, how are you as well? That's Anch, by the way, who's on the channel. Right, I'm going to crack straight on, guys. Today is Alkanes, is Organics Lesson 2 for AS, and we're focusing on alkanes today. So I'm going to crack straight on. I haven't actually, Anch, I haven't got the YouTube pop-up window up because everyone else is writing stuff, so I apologize for that. So 4 learning objectives, guys. I don't know why it makes me write so far down. It really bugs me. Doesn't matter. Right, I'll switch to tablet mode. Oh, okay. There. So first thing is be able to name all alkanes, including branched. So we're picking up the process of naming here, guys. So we're going to be building in nomenclature. By the way, I have got webinars on nomenclature that I need you guys to watch. I'm going to set them as a homework. I taught my year 11s how to name properly all the way up to A level. And actually, I'm pretty sure Hal Ping now in year 11 is better naming than I am. He basically ended up at first year degree naming, which is a bit weird. But I'll set you guys those as a homework to watch, and they're really good quality. Just watch them. So naming alkanes, know the steps in fractional distillation, understand combustion, and then know your pollutants. It's going to be a fast lesson today, guys. So first thing, let's do a bit of naming. So first thing is the subtitle is nomenclature. Sorry, what? Nomenclature, which is the posh word for naming. We all remember this. I'm going to make my pen a bit smaller. So this is naming. So at this point, I'm going to say, Aisha, name it, please. Let's see if you remember what I taught you last lesson. Well done. Good girl. Well done. That's butane. Great job. She recognized it was skeletal. She drew those carbons in her mind. Really pleased with that. That's great. Let's go for the next one. I'm going to go for Josh. Josh, can you name me this one, please? How many carbons? Well done. So what's 3 in naming? Well done. Thank you very much. Propane. I like it. Right, now we're going to start adding in some. So everyone here needs to be able to name up to 10. Yeah? Meth, eth, prop, bute, pent, hex, hept, ox, non, dec. Learn them. The first 4 are the only ones that really matter because the next ones from 5 and upwards are all just mathematical. Yes, everyone recognize that. The only one that people make mistakes with is 7. I don't know why they have troubles with 7. It's hept. Please don't write sept. I don't know why people want to do it, but they do. Please don't. Super common, drives me crackers. Anyway, so we can name straight chains. Let's now link in a couple of branched. So at this point, I'm now going to switch over to now being displayed. So here we go. So at this point, we now realize the first step in naming, is find the longest chain. Yeah, and so if I ask Yihan, what is the longest chain you can make here? Oh, I love the fact that you've given me in chemistry speak. That's cool. It's a prop. The longest you can make is 3. Is everyone okay with that? By the way, did I have to choose the carbons on the right? I could have done this, Harry, couldn't I? If I wanted to. There's no difference. These molecules, in reality, are kinky. Yeah? Whatever. So, and they are constantly bending, flexing, twisting, rotating. Yeah, so it doesn't matter if they don't draw it in an easy way. You just got to be able to go, right, where's the longest? Yeah? So watch out for those bends. Now, at this point, what we realize is, let's just make it easy and call that our longest chain. Now, at this point, you pick up what's called the stem name. At this point, that now becomes, it is based on propane. Is everyone okay with that? Now, I've got to now add, this is now what's called an attachment. Yeah? Or, better name, a branch. Now, we've noticed that the branch has a carbon in it. How many carbons does it have in it, please, Josh? It has 1. So it's going to start with the name meth. This is going to be meth. You guys are rubbish today. Come on. Whatever. So this is going to be a meth. It's a meth. Yeah, this is meth. But the problem is we can't call it methane. Yeah, can't do that. Yeah, can't call it methane because it's actually a branch. How do we now turn it into branch? By adding. Does anyone know? Look. Well done. The YL translates now in chemistry organics to branch. This is a prefix and it will now go here. This is methyl propane. and the aisle says branch. Is everyone okay with that? Not complicated? Harry, question. Oh, I love the fact that you're including the numbers. I'm coming to that, and absolutely it would be. The full name, if you wanted, was 2-methyl propane. In this case, you don't need the 2. Now, can I just point out, when I teach you naming properly, and you go onto the webinars, you'll realize that I just always say, just always put in the number. So I would actually call that as 2-methyl propane. But the 2 is technically not required. Now, I'm going to say to you guys, never, ever, ever don't put the numbers in. Just put all the numbers in. The reason being is you guys never really figure out when to not and when to actually include a number. So the best rule is just put them all in. Does this make sense? Yeah. The reason, Louis, why don't we need the number there?
Why don't if you focus on one, the first one, the third,
yes! Did everyone hear? Harry, did you hear that? You were talking to Josh, weren't you? Harry, I'll ask you the question now. Louis has given an amazing answer. Can you now repeat his answer for me? Why do I not need the 2? Why? If I attach it to the end, what does that become? Say it, say it, say it. Well done. It just changes the straight chain, changes the stem name. In that case, you don't actually need the number because it can't go anywhere else. Does this make sense with everybody? Right, let's try another one. At this point, I'm going to now slip nice and smoothly into skeletal. Let's do for this. Right, I'm going to ask Aisha, please. Can you now name this guy? So, step number 1, what's the longest chain? I like it, 4. I like it. There's my 4. Right, so now what's this here? How many carbons is it? So it becomes? We've just done this. Meth. 1 carbon is meth. Yeah? And it's a branch. So what does it become? Methyl. So this is methyl and stem name, longest chain, butane. Now, if I added a number, what would the number be here, Aisha? I like it. So just to tell you that the number goes in front of whatever you're numbering. Yeah? So if I said 2-ol, I'm telling you where the ol group is. Does that make sense? If I said 2-ene, I'm telling you where the double bond is. Does this make sense? So this is 2-methyl because I'm telling you where the methyl belongs. Can I ask you, why is it not 3? I like it because I can technically count from either end. And in this case, if I count from the green side, then it becomes a lower number, and I'm always going to go for the lower number. Does that make sense? Students at this point go, well, that's stupid, isn't it? Like, there's hardly any difference in it. And I'm like, well, if you've got 99 carbons, and it's on carbon number 98, you're not going to call it 98 methyl, whatever 98 carbons would be. You call it 2-methyl. Does that make sense? When it's really long, it makes a difference. Right, let's do another one. Let's do another one. So I'm now going to do this one. I'm going to go, oh, Harry, impress me. What's my longest chain? Thank you very much. My longest chain is 4. Now, what are these guys? They're each, by the way, they're not methanes, they're meats, and now they're branches, so they become. Okay, careful, just what are they? Methyl, and this one is also a methyl. So there's 2 methyls. How do we say 2 methyls in chemistry? Well done. Now, what would the numbers be? Oh, you've not said enough numbers though, have you? You've said 2 for this guy, but you haven't added the number for this guy. So it becomes 2, 2. No, they're on the same carbon, you numpty. Yeah, 2, 2, dimethyl, oops, butane. Are you with me, everybody? Josh, you're up next. Josh is like, oh God. Right, let's do it, Josh. Yeah, let's go for that guy. Looks like I have no idea what that looks like. Go! Well done. It is based on pentane. Thank you very much. Next. Oh. Don't tell him, Harry. It is a methyl. Where is the methyl? Thank you so much. To separate numbers and letters, you use a little dash. To separate numbers, you use a comma. You don't ever need to separate letters. Isn't that nice? Right? There's no separation between the methyl and the pentane. They roll straight together. But to separate numbers and letters, you use a little dash. To separate two numbers, you use a comma. Are we ready, Yehan? Are we ready? Oh, Yehan, whenever you're ready. Second. It is indeed. Well done. 1, 2, 3, 4. Oh, I'm going to go up there. Why not? 5. It is based on pentane. Now, what's this guy? Well done. It is a methyl. Sorry, I can't hear you with the face mask. That's all. I have to shout, you see. This is a methyl. And what number is it on? Well done, you star. This is 2-methyl pentane. Is everyone okay with this? This isn't massively complicated. It just takes some practice. We're going for the next one. Oh. Yeah, I'm going to go full display. Full display on this bad boy. Right. I'm going to ask Louis. Louis, can you name it, please? It's on it, right, guys? Yeah, is everyone thinking he did that faster than I did? Yeah, guys, I need all of you to be at that stage. If you can't do it at the pace that Louis just did it, you are not ready for your exam. No, Harry, this is not complicated. It's called practice. The more you practice, and guess where you practice? Doc Brown Organic Naming. Google, top link, go. Done. So this is, by the way, Louis is absolutely spot on. This is 2, 2, 4 trimethyl. Oof. That is some sexy chemistry right there. There you go. 2, 2, 4 trimethyl pentane. Boom, Louis. Ledge. Well done. Yep. You ready for the next one? Josh, are you ready? Are you ready? Right, Josh, can you please name me this one? Sorry, all H's. Longest? It's correct. Always on it. 3-ethyl. Well done, you led. Well done. See, guys, this isn't complicated. It just takes practice. You forget stuff. You've got to practice. If you don't practice it, you can't do it. Yeah? And you're going to have these on your exam. So watch out. Please, please, please. I do now need to mention the next one, which is this one. Please do this one. I'm going to ask Louis again, stretch and challenge and all that. Louis, name it, please, all H's. The question is, does he know 4? Longest chain? Well done. 2, 2, 3, 3, tetra. Tetra in chemistry means 4. Tetra, methyl, butane. We're done. I'm hoping that everyone's looking at these going, I can't get what he's doing now. Yeah, this actually isn't that bad. Yeah? Now, out of all of these guys that we've done so far, yeah, okay. Are they all 7? Oh, that's bigger. Oh, orcs. Okay, I'll leave it at that point. Okay, Louis, just for fun, if I wanted, I want to take that molecule there, and I want an isomer. Does everyone remember the term isomer? Yeah, molecules with the same molecular structure, different structural formula. And I said I wanted the highest boiling point. What would I do? Well done. I would straighten it out. What will it become? Well done. It would become octane. You just straighten out, put all the branches onto the end, and put them all together for the longest chain possible. It would have a larger surface area, therefore stronger van der Waals forces. We're done. Everyone okay with that? Winner. Right, so we can now do our first one. Tick, winner. Right, now we need to get onto our fractional distillation. So fractional distillation, new subtopic, please, guys. Fractional distillation. And I'm sorry this reappears. This isn't gone. They still love this at A-level because it was one of those stories. It's a 6-mark story and students never really learn it properly. And so they do love it. Now, I'm just going to quickly show you the stupid animation. Just really quickly. Oh, blimey. Gonna have to track this down now. Documents, you guys know I go through this every now and again. So files, pen drive, backup, teaching file, key stage 4 GCSE, year 9, module 1, crude oil, fractional distillation. That's not my folder. Oh no, it's an old one. Where's the new one? New one, unit 1, fractional distillation, crude oil, frac dis. Yes! Fractional distillation. I know what all my files are. You know, it's been a long time, but I've still got it. Brilliant. That's not what I wanted at all. Okay, that might be a disaster. Oh, no, it's all good. Oh, no! Oh, no! Uh-oh. Oh, they've got rid of Flash, haven't they? Oh, no! Oh, it's come to the end of life. What do I do? Oh, no, what do I do? Oh, no. That might ruin some of my... Like, how do you fix that, guys? Oh, no, someone needs to help me. Oh, no. How can I play a Flash file? Uh-oh. How do I play an SWF? Oh, I don't want to waste my time with this. I don't want to waste the time. Oh, I don't even know where my keyboard's gone. My keyboard's disappeared from down at the bottom. Oh, nuts. It should come up, but it's not. Of course, my laptop decides to do this right now. Okay. Oh, I can't even. Oh, you stupid thing. I'm just going to do it this way. Come on, just give me my keyboard. Stop being lame. There it is. So, fractional. I will have to sort that out now. Find another way of playing them. You guys remember these pictures, don't we? Yeah, the fractional distillation tower. You have to be able to give the steps in this process. You also need to know the fractions. Yeah, it's nice to mention all this stuff. So you remember that picture. So here are the steps that I need you guys to learn. Number 1. So steps. You've got to learn this. They're just going to ask you for the story. Step number 1, vaporize crude oil. Vaporize the crude oil. I don't know why I'm doing that. Vaporize the crude oil. That means to turn all of the oil into a gas. The word vaporize means become a gas. Yeah, we're then going to feed that gas, gas into tower, into frac dis tower. Now I have to tell them about the tower. The tower has a temperature gradient. And then we need to tell them what that gradient is. So it is hot at the bottom. It's got a hot bottom and a warm top. There we go. Hot bottom, warm top. Now we need to say what that means. Bigger molecules. Oh, I don't know why. Oh, I haven't capitalized all the F as well. Bigger molecules have stronger. Now we get to use the real term, because in GCSE we had to use the word WIMPs. We could know that's now dead. What, Josh, what intermolecular force is it? Thank you very much. Bigger molecules have stronger London dispersion forces, LDF, dispersion forces. Edexcel really loves that one. Everyone on the exam board prefers Van der Waals. So bigger molecules have stronger LDFs. Therefore, bigger molecules have higher boiling. Bigger molecules have a have higher BPT, boiling point, so condense lower in tower. We're done. 6 marks. Gotta know it. That's it. Learn that story. Next. Right. So the whole point of this, Aisha, what do we use this for? To get all the what? Wow. Are you going to write that down in your exam? You know it's wrong, right? Right, you said to get to all the fuels. What do you mean by get? It's the wrong word, get. Better word begins with S. This is to separate. Oh, there's a rat in separate. Separate fractions. Brackets. Yeah, to separate liquids. We know that crude oil is a mixture of liquids. And those liquids, those fractions, have different uses. So we're going to separate all the liquids because they have different boiling points. Agreed? Yeah, I like it. Separate liquids. Due to the property needed here, property is different boiling points. Different BPT. I like it. So at this point, guys, I am not going to now rant at you about you needing to know your uses. You do need to know your uses, and you need to know your fractions. Yeah, the top fraction is natural gas. The second one is petrol. The third one is naphtha. Naphtha is used in the petrochemical industry. It's used to make more petrol. It's used in cracking. Then it is naphtha, kerosene, diesel, lubricating oil, fuel oil, bitumen. You've got to know them. And each one has a different use, and it's up to you to learn them. By the way, if you're interested, go to the internet and just there they are. Yeah, just learn those. Gas, petrol, naphtha, kerosene, diesel, lubricating oil, fuel oil, and bitumen. Don't call it residue. Yeah, it's bitumen. Yeah. So anyway, it's up to you to learn them. It's GCSE. That's just bulk knowledge. Go on, Harry. To produce what? Clothes. Yes, because they crack it to make alkenes, and alkenes are used to make polymers. So you wouldn't say to use to make clothes, because it's used to make more petrol, and so you just say in the petrochemical industry. Yeah, and really it's to make alkenes. Still not a good. They always. I mean, we're coming to cracking soon anyway. So it is up to you guys to learn those steps. Yeah, the next thing, combustion. Right. New subtitle, please, is combustion. Can I just point out, everyone loves this one, right? This is like the favorite one. Yeah, this is combustion, this is burning. We love burning stuff. I love burning stuff. It's basically why I become a chemistry teacher. I get to set fire to kids. No, to stuff. Oh, I'm live on YouTube, aren't I? That wasn't a good thing to say. I take that back. I don't really. Yeah, no. So combustion is the posh name for burning. So first thing is, Josh, what type of combustion are there? Thank you so much. Complete and incomplete. How many versions of complete are there? Okay, I'll change the question to make it easier for you. How many types of incomplete are there? Huh? If you don't know, just pass. It's fine. Harry, I told you the GCSE. Well done. There is one complete. Yeah. And Aisha, how do we get complete combustion? 1 mark. Oh, wrong word. Pure's going to let you down there. Louis. No, good effort though. Oh God, we need to talk about saturated and unsaturated. Yihan. Something oxygen. How do you get complete combustion? She said pure. Nope. She said saturated. It's kind of on the better lines. It's another word. Harry. Josh. I'll give you the starting letter. Man, we'd be playing Hangman here if it wasn't the fact that you got mocks in 2 weeks. Here. Someone shoot Harry, please. Someone please shoot Harry. Oh my God. Kill me now. In order to get complete combustion, you must have excess oxygen, more than enough. It's the only way you can get complete combustion is excess oxygen. Right. So what that means is incomplete is not enough oxygen. Not enough O2. Yeah? Okay. So, Louis, excess oxygen. If I take X and I burn it in O2 and I'm going to write underneath it excess, what am I going to make, please? How do I know it's complete? Oh, I'm going to make water, and is the right answer. You know it's complete because of this guy. You get CO2 and water every time, and it's the carbon dioxide that tells you it's complete. Because if I now take X and I burn it with not enough oxygen, insufficient, if you will, yeah, what am I going to make, Harry? Yes, CO and water. I'm going to ask Josh, what do you know about carbon monoxide? Well done, it is toxic. Let's stick with chemistry words rather than icky, sticky, squishy biology words. So we're going to get toxic carbon monoxide. If I now take X and I burn it once again in insufficient oxygen, what's my other choice, please, Louis? Oh, I like it. Well done. So that would be what's in the... I'm going to get C. Now, what do you know causes a... Oh, no, carbon monoxide is a gas. My apologies. What does this cause now, please, Louis? Carbon particulates. What global problem does it cause? Not sure? Not global warming. No, global warming is carbon dioxide. Aisha, I thought you were GCSE. Oh, Harry's got it. I hate you. I hate you. You heard? It doesn't affect soil, no. If anything, it would be good for soil. They like carbon as a thing. Go on. Josh? These are called carbon what am I doing there? Ahead of myself. Carbon particulates. Oh, I've gone mad. Particulates, and they cause global dimming. Does anyone remember it? Aisha? I taught you this. I even showed you the videos of the Q80 oil fires when it blocked out the sun. Yeah? No? Whatever. Anyway, so we just have to know all of these things. So what does carbon dioxide cause, please, Josh? Thank you very much. This is global warming. Global warming. Yeah, by the way, at this point, we need a nota bene. We need a nota bene. Does there anybody, so nota bene, nota bene. Why am I singing Christmas? That's what's going wrong with me. So global warming is caused by greenhouse gases. Caused by greenhouse gases. And we've got one. So we know that carbon dioxide, so CO2 is the one that everyone's talking about, your carbon footprint. Yeah, but there are others. Josh, do you know any other greenhouse gases? Well done, he's on it. It's methane. Methane is also a greenhouse gas. Can I just point out, by the way, that that's an awkward one in terms of the science. It's one of the ones which is kind of problematic a little bit. There is another one as well. Anyone else want to guess at another gas that causes it? Oh, it's correct. NO and NO2, they also cause it. But in reality, we don't tend to talk about those guys because they cause a much bigger problem. Harry? What problem do these guys cause? Yes, these cause acid rain. But they are greenhouse gases as well. They are. There is one more that we must talk about. It's water. Well done. It is water vapor. So water vapor also is a greenhouse gas. Now, just to make a quick note here as well, which is, and this is where the methane is a problem. Yeah, because the reason why molecules with polar bonds can absorb infrared radiation. They're absorbing the infrared from the sun and trapping it in the atmosphere. Now, this is an awkward one because methane technically has non-polar bonds. Yeah, sorry about that. And unfortunately, it is a problem. The students have to go, well, hang on a sec. You told me that the carbon hydrogen bond isn't polar. I'm like, it's not polar. But it is actually minorly polar, but it's not actually classed as polar, but it still is polar just enough to absorb infrared radiation. It doesn't absorb a huge amount. Do you want to see? Just to show you this, guys. So check this out. So carbon, oh, now my laptop decides to do what I'm asking you to do. Carbon dioxide infrared spectrum, please. So check it out. So this is an interesting graph now. You're going to learn about infrared later. Now the graph is upside down, by the way. So what you can see is that it actually starts off at 100, and these peaks are not called peaks; they're called troughs. The graph is awkward; it's literally flipped over. So usually we see a peak in a graph from 0 and up. Now we're getting the reverse, which is what it's saying is that the light shining comes in as 100%. It hits the molecules, and then we measure how much comes out of the side. Does that make sense? So if we have nothing in the gap, if I shone that light straight at the sensor, it would be 100%. Does that make sense? And then you see something the other way, like if I stick my hand into it, it's going because I'm absorbing all of it. Yeah? And certain molecules absorb certain frequencies of infrared rays. And so you can see carbon dioxide doesn't absorb a huge amount. Thank God. God, if it absorbed any more, we'd be in real trouble. Yeah? But look, you can see it's absorbed. So I'm going to copy that. I'm going to show you this. So I'm going to steal you. That didn't work. Oh, come on, laptop. Do it on my, yes, copy image. So let's just show that this is something, this is a thing. Paste. Yes. So the carbon dioxide absorbance, zoom, zoom, is here. I'll color it in green. Absorb, 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 and then absorb. Yep. So it's got a little baby absorption. It's only small. It's not massive. Do you want to see what it looks like for methane? It's always nice to compare these. So let's switch that now for good old methane. Your methane. Gone London. So methane is also absorbing infrared radiation. Yeah, and you can kind of see there's a bit of a blur. This one's a bit blurry. It's not a solid absorption, quite like CO2. Maybe that one's probably better. There you go. But it's absorbing probably somewhere similar. Maybe even a bit more. I think it's probably about twice as much, 2-3 times as much. So methane's not good for that's why, the whole cows farting thing. I just point out that's really not the problem. The problem is the carbon dioxide we put in the atmosphere is causing the ice caps to melt since the global temperature is increasing. The ice is melting and it's exposing the land underneath it, which is covered in rotting plant material from the previous ice age. And that's now rotting and turning into methane and flooding the atmosphere with methane. We are totally and utterly done. Like you guys are gonna have to live through this. I'm dead by that point, but whatever. So methane. Do you want to check out water vapor? Holy guacamole! Now this is a bad greenhouse gas. So this is steam infrared spectrum. That's not his spell spectrum. Check it out. Boom! Look at that! Holy moly! Now that is some serious greenhouse gases. So should we be worrying about carbon monoxide when the water that we're pumping into the atmosphere, look at its absorption! Oh, no, it's basically like all of it. Guys, we don't worry about water vapor, do we? Why? Lol. Anybody else? It's natural. So is carbon dioxide. Second. Right, because the water doesn't stay in the air. No, it's not close enough, Louis. It's terrible. Guys, it doesn't remain in the atmosphere. It comes back down as rain. We can put as much water vapor up into the atmosphere as we like, and it will return to the ground as rain. Yeah, which we're quite lucky about. As the temperature rises on our planet, what happens to the amount of water coming off the oceans? Oh, therefore we're putting more greenhouse gases in the atmosphere. We have no idea how far global warming goes. It's not even called global warming anymore. It's called climate change. And we are like, if we think we can stop this, we can't. We've already built in enough of we're just waiting for the lag time now, guys. This is like my YouTube videos. Yeah, we're just waiting for that 20 seconds for the wave of consequences to catch up to us. We are so in trouble. Let's move on. So, water vapor, bad greenhouse gas. Do you want to see NO2? Let's just for fun and games. Let's see NO2. Nitrogen dioxide. I can't even spell it. Go! Come on, there we go. Look at that! Boom! Dioxide, there you go. So it's got a huge absorbance. Yeah, that is also not a greenhouse gas. But we're very lucky because this doesn't stay in the atmosphere either. What happens to the NO2? No, what? What do you think plants do? They don't use nitrogen dioxide. Are you okay, Louis? I think maybe you did, or maybe I should feed you some now. It might be better. So the answer is no, plants do not take in nitrogen. Nitrogen dioxide dissolves in the water to turn into acid rain and returns to the ground. Yeah, it actually reacts. By the way, it actually reacts with the water to form nitrous and nitric acid in the water. Yeah, and then so returns down, so it doesn't stay there either. The one that's causing all the problems is carbon dioxide. Now, by the way, carbon dioxide also gets absorbed by the rainwater and comes back down as carbonic acid. This is why the oceans are acidifying. The oceans are absorbing 90% of the CO2 we're putting out, but the other 10% is remaining in the atmosphere. Oh, we're so dumb because as the ocean's acidifying, all the coral reefs are going to get killed within a matter of years. You know, in a decade, they're all going to be gone. Then that destroys the entire ecosystem of the ocean. We lose all of our big main plants and basically anything living in the ocean than jellyfish. We're so dumb. Moving on. So, great job, amazing. We're doing really well. I'm basically telling you, you just the world is toast. So, we've got all these lovely gases. So, and we're continuing to burn fossil fuels at the rate of, like, I don't know, 600 billion. I'm just going to freak you out even more. Let's do it. I might as well. So, have you ever heard, you guys have probably, because of the coronavirus, heard of Worldometer? No? How are you guys tracking all of the numbers in Malaysia? You don't, brilliant. So you just don't care. Amazing. So this is what I've been using this website on the phone just to track the number of cases in Malaysia. But it also, rather than this, I actually knew, I knew this website before the coronavirus came on because it does really cool stuff. So all it has at the moment is coronavirus. That's all they really care about anymore. It's a disaster. So let's go back to the top because what I want to do is actually measure something other than the terrible things that are going on. So let's just do population. Oh, the problem is they've got rid of everything else because this is just dominated. That really is rubbish. So let's do Worldometer. Let's just do Worldometer oil and see what that gives me. There we go. World oil statistics. So consumption, guys, oil left in the world is ticking down, and look at our oil consumption. So we are using 97 million barrels per day. Guess where all that carbon's going? Into the atmosphere, and 80% of it, 80 to 90% of it is going into the oceans. Like, be scared. Anyway, moving on. No. You are going to experience this firsthand. Like, this is going to be, for the next, don't get me wrong, we are currently living in what I believe to be the peak of our civilization. Like, because in the next 10 years, I mean, Australia is going to burn every year just for one. They are the first country that's being hit by this. The amount of flooding that's happening in Southeast Asia is increasing rapidly. In the next 10 years, there are going to be countries that will become uninhabitable. And where do those people now go? They become refugees. They have no home, no access to clean water, no access to food. They have to go to other countries. Other countries now, you're going to see this firsthand. Now, don't get me wrong. You guys are in the top. You guys are in the top 2 percentile of the world's wealthiest. Like, that's kind of cool, right? Like, that's where you sit. And there are people in this room going, you know, I mean, I'm a teacher. I'm like, I'm not rich, but I'm still in the top 2 percentile. Yeah, because we realize that 0.02% of the world's wealth is held by all of those people. It's crazy. Like, it's ridiculous. And all these other people, like the price of fuel is going to go up, price of food is going to go up, price of water could become the next gold. Yeah, as people start running out of clean, drinkable water. So all of a sudden, there are going to be wars over water. People will die. Yeah, I'm going to stop. I'm sorry, I'm ranting. Next, so combustion. We've talked about combustion. You know, by the way, lots of equations. I do need to mention a whole load of other people. So I know I've lost it, haven't I? So just to mention, you know, if I was burning X, you know, burn X. Well, and I'm sorry, I was not in a depressing conversation. So just to quickly mention, what would happen if X contained sulfur? If X contains sulfur, what will I generate? I will create SO2. Yeah, if X contains any atoms of sulfur, I am making SO2. SO2 contributes to acid rain. Yeah, so let's look at how it does that. The reason being is the SO2 dissolves in the rainwater and turns into sulfurous acid. Not sulfuric, sulfurous. Now you need to be grateful for this, because if it was turning into sulfuric, we wouldn't be walking around going, oh yeah, acid rain, that's a problem, isn't it? Don't really tell, to be fair. We'd be walking around with umbrellas going, I'm melting! Yeah? So thank goodness it's sulfurous. What happens if X contains nitrogen? What will I create? I will create nitrogen dioxide. I will actually form a mixture of nitrogen monoxide and nitrogen dioxide. It will be a mix. And they will tell you in the exam question which one they want. Is that okay with everybody? Yeah? Because now, in reality, what we realize is all cars generate some form of nitrogen oxides. Can anyone tell me why? When there's no nitrogen in the fuel. That's weird. How can a car generate nitrogen oxides if there's no nitrogens in X? The reason being is, where's it getting the oxygen from? From the air. Cars breathe. Yeah, everyone knows this, that cars have an air inlet. Yeah, if you don't know, they do. They breathe. They take in air. And what does the air contain? It contains 78% nitrogen. And that nitrogen can react with oxygen to form NOx. They will tell you in the exam, which. Yeah, and then you balance the equation as necessary. I'm going to do NO because it's easier. There we go. So the nitrogen is coming from the air. Is everyone okay with this? Yeah? Cool. I like it. But let's add on a little bit of detail here. Because so I drive to school every day, like 10 minutes. I live in Tropicana. Yeah, it's not very far, like 10 minutes away. And actually, in terms of NO output or NO2 output, in terms of those, I actually produce next to none. I produce a little bit, but I produce less. The reason why is because in order for this reaction to happen, can you make a little nota bene, please? Yeah, nota bene. Yeah. So for this reaction to happen, we need high temperatures, high temps, and we need a spark. We need a spark. Now, Harry, you're into cars, right? Yeah, so where's the spark in a car? Sure, above the piston. Yeah, top of the cylinder casing. Yeah, so in a car engine, just to now show you, I would show you my animation, my flash animation, but I can't. Stupid internet changing stuff. So, car engine cross section. So in a car engine, this is where if I had an animation, it'd be super useful. Oh, I do have an animation, but I can't use it anymore because the world sucks. So there we go. Nope, that really doesn't help me because there's no spark. Oh, are you having a laugh? I hate you. Car engine cross section. Right. Come on, just give me one cylinder, you stupid thing. Right, there we go. So go back. Now, I just closed the tab. Okay, that'll do. I'll take you. Right, guys. So each cylinder has a spark plug there here. So if the cylinder moves up and down, yeah, this is what turns your car engine. Yeah, the cylinder moves down, it pushes the crank wheel around. I'll show you the animation when I get it working. Yeah, when the cylinder comes back up again, we inject fuel, and we spark it once it's burned, which creates those gases. The gases expand, pushing the cylinder back down again. Make sense? So there's a spark in a car engine, and that is what mainly produces the NO. Now, I produce less NO than NO2 on my journey because I'm only driving for 10 minutes. Once you get to like 20 to 30 minutes, you're producing a much higher amount of NO and NO2 because the temperature of the engine is much hotter. Now, the reason why this is happening is because the nitrogen has a triple bond. Whoops. This is a very tough bond, folks. And to break that bond requires an awful lot of energy. Yeah, go on, Harry. So a turbocharger adds more air into the system. Yeah, and it will definitely be hotter. So one of the problems when you add, so if you ever decide to go into modifying cars, you know, people love to add on turbochargers and things. Well, if you do that, one of the things that you must address is the cooling issue. You have to add in a much bigger radiator because the car's going to get a whole lot hotter. So yes, you'll produce more. Yeah. Also, the more spark plugs you have, so the number of, so there used to be V16 engines and V12s. They're disappearing now, and we're preferring V8s. Yeah, because they're slightly better for the environment. Not by much, but a little bit. Okay, going back to my learning objectives. So we've covered combustion and we've done pollutants. Yeah. So technically, guys, I've ticked off all my learning objectives. I will end my lesson there today. I'm a little bit over. Oh, this laptop's killing me. There we go. I'll end the lesson today. I hope you found it useful, Ange. I've got loads of people commenting on stuff, and everyone's just laughing at me. Oh dear. Likes and dislikes, I'm suddenly just, oh, that's sad. Oh dear. Anyway, I'll leave you guys be. Have a good day, everybody. No.